deep in the Western Balkans lies a geographical nucleus of giants. In regions like Herzegovina and Montenegro, the average height of young men reaches an extraordinary 184 to 185 centimeters, over 6 feet. Some urban averages are even higher. For decades, scientists have asked, why? Is it the food? The mountains? Is it the high calcium content in the limestone mountain range that supports bone growth? Or is there a ghost in their DNA? Today, we're looking at the unexpectedly complex and often controversial origin of the Dinaric Phenomenon. At our university, we address the issue of extraordinary height of Dinaric Highlanders in extremely demanding research conducted from 2015 to 2017. In collaboration with colleagues from Croatia and the University of Montenegro, we measured the height of 5,846 high school students, aged 17 to 20, across 163 schools in 60 cities. This research received considerable international acclaim, although it did not solve the problem itself at the time. However, we obtained very valuable data that later helped to unravel this conundrum. The question of Dinaric gigantism was first addressed by the American anthropologist Carleton Coon in the 1930s. In his book, The Mountains of Giants, he collected his findings from a trip to Albania, during which he intensively studied the anthropometric measurements of local mountaineers. At that time, he hypothesized that the extraordinary height of the Gegs in northern Albania could be related to the limestone bedrock of the Dinaric Alps. The calcium contained in the soil enters the water and the food chain, and could contribute to the acceleration of physical growth and the massive skeletal structure that is typical of the local inhabitants. However, in the last 3 decades, genetic research has shown that the answer should rather be sought in the specific genetic origin of the Dinaric people. If you look at their DNA, one signature stands out: Y haplogroup I. Y haplogroups are mutations on the male Y chromosome, which are inherited from father to son. Although the Y chromosome carries only a limited number of genes related to male sexual functions, Y haplogroups can act as a marker of male founder events, the rapid spread of genes linked to a single dominant male originator. In Herzegovina, the frequency of Y haplogroup I reaches a staggering 71%. Currently, Y haplogroup I has 2 main frequency peaks in Europe, in Scandinavia and in the Western Balkans. While in Scandinavia, we find mainly the subbranch I1, which is, by the way, the Y haplogroup of my Viking great-great-grandfather. In the Western Balkans, it is a subbranch called I2, characterized by the mutation P37-2. Y haplogroup I is a legacy of the men from the so-called Epigravettian culture, which was widespread in Italy and the Western Balkans at the end of the last glacial maximum. Genetically, members of the Epigravettian culture belong to the so-called Villabruna cluster, named after a site in the Italian Dolomites. These Mesolithic hunter-gatherers are best known from sites at the Danubian Iron Gates and were remarkably robust and tall. Around 14,000 years ago, groups carrying the Villabruna component expanded across Western Europe, settling Scandinavia and penetrating as far as the Baltics and present-day Ukraine. As a result of the expansion of Anatolian farmers and later, the warlike herders of the Yamna culture, the proportion of the Villabruna component in modern Europeans dropped significantly. It is still most prevalent among the Baltic peoples, whose male lineages have since been replaced by the male lineages of the Yamna culture and Finn-Ugric hunter-gatherers. Therefore, in all 3 European regions that are now above average in height, Scandinavia, the Baltics, and the Western Balkans, we find some form of the genetic legacy of the Villabruna cluster. Is this just a coincidence? Hardly. This indirectly proves that the genes of the Villabruna component carried the prerequisites for exceptional physical height. And modern genome-wide association studies do attribute exceptional genetic predisposition for height to the Villabruna cluster, although they cannot yet agree on whether it was higher or lower than in the Yamnaya steppe pastoralist cluster. But the story is not so simple. Paleogenetic research has shown that the lineage Ita P37-2 survived the Neolithic expansion in the Balkans, and along with the related lineage Itwa M223, was widespread throughout the Neolithic, Eneolithic, and Bronze Ages. However, both these two lineages disappeared from the Balkans during the Iron Age, about 3,000 years ago, only to reappear during the early Middle Ages. This has led many to believe that the surviving lineages of Aitwo in the Balkans are descended from a population that mixed with the ancestors of the Slavs and returned to the Balkans during the Slavic expansion. And indeed, a recent study showed that early Slavs in Central and Southern Europe had both the typically Slavic Y haplogroup R1 and the supposedly Balkan Y haplogroup Itua. However, most of the Ita lineages found in the Western Balkans today belong to a specific mutation called PH908. Its most recent common ancestor lived relatively recently, around 300 AD, shortly before the Great Migration period. The subbranches widespread in other Eastern European regions are different. Unfortunately, the authors of the above-mentioned study did not use a particularly high resolution of Y haplogroup lineages, so we cannot say if the detected Slavic subclades of Itwa also included the Western Balkan subbranch PH908. And as if these mysteries were not enough, it turns out that the Dinaric phenomenon also shows a very eccentric relationship with autosomal components. The Villabruna component, which was historically linked to Y haplogroup I, and is, next to the Yamnia component, the most important autosomal predictor of height in Europe, does not actually explain the extraordinary height in the Western Balkans. It even correlates negatively with it. The same applies to the Yamnia component. The height of the Western Balkan peoples actually shows a very linear relationship with the Anatolian agriculturalist and Caucasian hunter-gatherer components, which are predictors of short stature in other European regions. What's more, despite the very high frequencies of Y haplogroup I in the Western Balkans, local height averages can be better explained by the Paleo-Balkan Y haplogroups E1b, J2, and R1b, which were typical of the Bronze Age Balkans and are associated with Near Eastern and Yamnia populations. Curiously, they also predict shorter height in the rest of Europe. That's a tricky thing, isn't it? I must admit that this problem gave me a headache until I realized that I must dig deeper to the Bronze Age period of the Balkans, when the core of local populations formed. I turned to the commercial website ancestralwhispers.com, which provided me with data from their Global 25 database, a rich source of information on multiple prehistoric and modern European populations. I identified 5 basic autosomal components that were typical of the Bronze Age Balkans or later immigrants from other parts of Europe, and tried to correlate them with both the body height of modern European peoples and the spread of Y haplogroups. To my surprise, it turned out that modern Herzegovinians have a very high percentage, 50%, of local Paleo-Balkan ancestry typical of the Bronze Age Adriatic region. This ancestry is also able to explain the differences in male height among the modern 12 Balkan populations. Given that Paleo-Balkan ancestry contains a significant portion of Near Eastern genetic heritage, this can explain the unexpected positive association between male height and Near Eastern components in the Western Balkans. Notably, the only Y haplogroup that currently shows a significant relationship with Paleo-Balkan ancestry in the Balkans is Itwa. As you move towards the tallest populations in Herzegovina, Slavic ancestry actually decreases. The most important predictor of short height in the Balkans is Minoan ancestry, which characterized Bronze Age Greece. On the other hand, the graphical comparisons also support the assumption that some Ita lineages expanded with Slavic migrations from present-day Ukraine. A possible secondary expansion of Slavic ancestry, Paleo-Balkan ancestry, and Ita could have occurred from the vicinity of Bosnia. Interestingly, The three Paleo-Balkan lineages that positively correlate with male height in the Dinaric Alps were associated with Paleo-Balkan ancestry during the Bronze Age, but are now strongly associated with Minoan ancestry in 11 Balkan countries. However, traces of some positive association with Paleo-Balkan ancestry are still evident in the former Yugoslavia, Moldova, and Romania. This ambiguous affinity is particularly evident in the case of Y haplogroup J2, which was the dominant Y haplogroup on the Dalmatian coast in the Bronze Age. And what does this mean? My current hypothesis assumes that Paleo-Balkan ancestry was originally linked to all four of the mentioned Y haplogroups. While in the case of men carrying E1b, J2, and R1b, this relationship gradually weakened through admixture with other Balkan populations. The carriers of the PH908 subbranch likely retained their Paleo-Balkan heritage by remaining isolated in the rugged inland mountains of Bosnia and Montenegro, areas that paleogeneticists have largely neglected. In fact, modern Herzegovinians do not have any traceable amount of Minoan ancestry from the southern Balkans, and can be modeled as a roughly equal mix of local Paleo-Balkan people and Slavic invaders. This combined population then expanded from the area of present-day Bosnia and spread the mutation PH908. In any case, it is clear that the Slavic origin of PH908 would require a very eccentric admixture scenario. And where did the extraordinary predispositions for physical growth come from in the Paleo-Balkan populations, when their autosomal origin goes back mainly to Near Eastern farmers? Although this is again speculation, I believe that the genes for physical gigantism were maintained thanks to founder effects of Y haplogroup Itua. It is difficult to imagine that strong selection for body height could have taken place in this mountainous region, which is characterized by very poor limestone soil and a lack of resources for subsistence. We will have to wait for more sophisticated genetic research, but it is already clear that researchers will have a difficult task, as the inhabitants of the Dinaric Alps achieve only average or below-average polygenic scores for height, based on genome-wide association studies. In other words, the height genes that have been identified in Western Europeans completely fail to predict height in them. One thing is certain: the Dinaric Alps remain one of the most fascinating genetic laboratories on the planet, and hopefully, future research will finally and forever solve the enigma of the Dinaric height.